practicing stuff. One of them is from O levels, and one of them is from IGCSE. Both are actually equivalent levels. It's not a big issue. So, but I just consider that I should discuss variety of questions with you people, right? So here I have this topic from you for you. This is your from your O levels. So both of you are in O level stream, na?
Yes.
No, sir, I'm in Igcse.
Oh, great. तो गुड हो गया. एक को आईजीसीएसई की समझाएंगे, एक को ओ लेवल्स की समझाएंगे, बल्कि दोनों को मिक्स समझाना पड़ेगा, है ना? Yes. So both topics are same. Question pattern is same. Question weightage is same. So I will discuss fewer questions from this from O levels worksheet and fewer questions from your IGCSE worksheet, right? So here some MCQs are there, which are good MCQs from O levels. So a student carries out an experiment to plot an extension and load graph for spring. The diagram shows the operators. Diagram shows the operators at the start of uh, yes, at the start of the experiment and with the load added, right? This is that operators which is shown at the start of the experiment, and this is that which is at the end of that. So what is the extension caused by the load? So it's very easy understanding for the extension. That extension is always final length minus initial length. So it would be quite easy for you that it will be y minus x. Okay, got it?
Yes.
Okay.
Yes, sir.
Then a student adds a load to an elastic cord. Okay. He measures the length of the cord for each weight. Then he plots the graph from the result as shown, which length has plotted on the vertical axis. Right. This is the load, and which length is on that side. Initial length, final length, or channel length, whatever. So what's your idea? Mira, did you gone through this topic? Sorry, I did not ask you.
Which topic is this?
This is deformation, springs, and elasticity, Hooke's law.
Hooke's law. Yes, I have.
Okay, so you have to recall your concept. So if it would be there would be any sort of problem, then you can ask me right at the spot, so we can discuss that. So yes, Hassan, how are you?
Alhamdulillah, सर आप सुनाएं.
Fine, Alhamdulillah. तुम late join करते हो, time पे आया करो. Okay, so Hassan, let me know which would be this y-axis length. Okay, continue, hurry up. So when I will ask you a question, so please be vigilant. Okay, Hassan, is this question clear to you? A student adds some weight to an elastic cord, and then he measures the length of the cord for each weight, and then he plots the graph from the result as shown in the figure, which length has plotted on the vertical axis, I mean y-axis. So which is that length? Who will tell me? Mirab, Yahya, or Hassan? Any one of you?
Measured length.
Measure length? Option A? Yes.
Measure is minus origin.
Okay. So you are going to lock option C?
Yes, because it starts
Okay.
with-
Okay, Mirab, are you agreed?
Yes, I think option C.
Option C. And Hassan, what about you?
C.
C. Why? Because actually this is extension. So when I talk about extension, extension is final length minus initial length. So remember one thing, when the graph is extension load graph, it starts from origin. But when the graph is not extension load graph, it is measured length, I mean final length and load graph, it would appear like something like this. Okay? Is this question clear to all of you?
Yes, sir.
G.
Okay, then question number 3, which plot of the graph shows the limit of proportionality for the elastic solids? So I have explained this topic or explained this question, that whenever there would be, you will have a straight line, something like this, and then plot your or place your ruler along with this. Okay, ये देखो, I have placed the ruler along with this. Wherever the point where ruler and the line are going to be separated out, that is my elastic limit of proportionality actually. So in this case, option C would be correct then. Is it?
जी sir.
Okay. Is it clear? Should I go to next one? जहां पे मसला हो आप लोगों ने मुझे बताना है. Okay, both of all of you will get an extension load graph for a wire is shown. It is extension and load graph. What is the load at the limit of proportionality for the wire? So where is the limit of proportionality? First of all, I have to figure that limit of proportionality out. The yes, here is the point where graph
60.
and yes, this is the point. So first I will figure out that point. This is my point where the graph is separating out from the from the ruler. So at this point, this is load. So at 60 Newton load, actually what I have limit of proportionality. Is this clear to all of you?
Yes sir.
Yes.
Okay. Now check this one. I will discuss few of the questions from this and then I will go back to the theory one. A table shows how extension of a spring varies with load. Extension varies with load. So for zero load, zero extension, 2 Newton load, 3 centimeter. For 4, it is 6. For 6, it is 9. So between which two loads would you find that the limit of proportionality is obtained, or would you find that limit of proportionality is there? So for limit of proportionality, as I told you, that extension will be no more proportional to the load. So in this case, when the table is given to you, you have to check for every 2 Newton change in the load, there is a 3 centimeter change in the length. So here this difference is 2, this difference is 3, this difference is 2, this difference is 3, this difference is 2, this difference is 3, this difference is 2, this difference is 3. Here this difference is 2, but what about the difference in the extension? It is 5. It means in between 15 and 20 centimeter we are getting this thing, this limit of proportionality, and for the load for that is between 12 to 10. Sorry, 10 to 12. Is it?
Yes.
Yeah. Is it question clear to you?
Yes sir.
Yes, sir.
Yes. So this would be giving you option C, right? Now let's have some other graphs or questions from the other worksheets. Then I will come back to the same one for the MCQs ones. Let's talk about some theory questions for from another reference. This states Hooke's law. So what would be Hooke's law? Can anybody tell me? For 1 mark. Any one of you? Yes. Uh-huh. Yes, yeah, you can. If you people, any one of you are ready, just tell me that, sir, I can tell. Then I will permit, no issue. Yes, who is ready? Mirab?
Sir, I don't really remember definitions.
Oh, good. Hassan, your 35% is on memory recall. So please recall all these statements or all these definitions and yeah.
Um, I don't know how to define either.
Oh my God. So all all of you scored 0. Okay, within elastic limits, extension is directly proportional to the load. It's very simple, na? Extension and load are directly proportional to each other. That's it. Very easy definition for you. directly proportional to each other. Okay, so in exam you have to write this within elastic limits. Extension and load are directly proportional to each other. Now for a force, for forces up to 120 newton, a spring obeys Hooke's law. It means a spring is obeying Hooke's law for up till 120 newton. This is a very important information. You have to consider that equation information. A force of 120 newton causes the extension of 64 centimeter. How much? 64 millimeter. On figure 2.1, draw the force extension graph of the spring till 120 newton. So we have one information given from the examiner and one information we know from ourselves. That is, at 120 newton load, what will be the extension? 64. So सबसे पहले 120 newton आप mark करिए. It is 100. Then it would be 110. Then it is 120. So this is my 120 newton load. Got it? And then I will figure out 64 millimeter extension. So 64 will be 2 4. It would be 64. Is it? So for these two, I will basically mark a point over here at this position, and then I will join this. Yeah, that is correct. Sorry, not this one, this one. This is the point where I have to reach by the graph. So I will draw the graph from origin. This is very important for that graph. And then you can erase these two lines, which are basically the reference lines for you. Now this is your graph. Got it? Is it clear? उसने ये बोला हुआ कि you have to draw till 120 newton. So the 120 newton is over here at this point, and at this point the other value is 64. So 64 and 120 newton is this point. Is this clear to all of you?
Yes, sir.
Yes, sir.
Calculate the spring constant. तो आप लोग मुझे ये बताइए कि when I talk about the spring constant, do you know spring constant is K, is it? And the equation for force according to Hooke's law, F is directly proportional to X. And if I say F is equal to K times X, and from here K will be equals to F divided by X. Is it? K is equals to F divided by X. So what will be K by the way from this graph? Because F is along your y axis and X is along your x axis. I mean extension is along your x axis. So should I say that this K is equals to gradient of this graph? Should I say this?
Yes, sir.
Because देखो y axis is force, x axis is your extension. So actually this is your gradient. Y2 minus y1 divided by x2 minus x1. Or in other words, you can say this is your rise and the other stuff is your run. This one is your run. So when we talk about this, that this is the gradient, तो आप लोग gradient calculate करिए. So its gradient is basically equals to K. And what will be K then? The final value is 120. 120 minus 0 divided by, because rise is y2 minus y1, and run is x2 minus x1. So x2 is 64 minus 0. So what will be answer? Do you have any calculator with you?
1.875.
Yes, 1.875. But the important thing is this is Newton per millimeter. What is that? It is Newton per millimeter. So I have to convert this 64 into meters. This is 64 millimeter. Na? So what I have to do, I would write 120 divided by 0.064. Now let me know what is the value. शाबाश कैलकुलेटर है.
जी sir.
Okay.
1875.
Yes, 1875, which is almost equals to 1880. And for two significant digits, because the data is represented for two significant digits, so we will write this number as 1900. What will be right? 1900 Newton per meter. Okay,
Yes, sir.
is this clear to all of you? Any question in this one?
No.
No, sir.
Okay, हसान आपका कोई क्वेश्चन बेटा?
नहीं.
मीरब आपका?
No, sir.
Okay, then the next is a student makes a spring balance by using the spring in B. The maximum reading of this spring is 150 Newton, right? The maximum reading of the balance is 150 Newton. The student tests his balance with a noun weight of 140 Newton. Then he observes that the reading of the balance is not 140 Newton. You have to comprehend this statement, and you have to link this with the previously given data. Our limit of proportionality was 120 Newton. Okay, and student is measuring 140 Newton. But uh, when he has a test of this weight, it is calculated that, or it is observed that it is not 140. Suggest and explain why the reading is not 140 Newton. Who will explain this? Did you people get the question?
Sir, can you explain the question again?
Yes. My question is, the spring what we are using, its limit of proportionality is 120 Newton, right? Is this clear?
Yes, sir.
Okay. Now, in part C, it is said that a student is making the spring balance from the spring in B, whose limit of proportionality is 120 Newton. The student wants to make a spring balance from this spring, and he measures the maximum reading of this balance is 150 Newton. What is the highest reading on this balance? 150 Newton. Okay, I will draw a diagram. Let's say here this is a balance, spring balance, right? And he is going to make a balance by this spring, and the reading on that is 0, 10, 20, 30, 40, 50, 60, and so on. And that reading is basically, it is reaching to 150. So this is your 150. Okay, are you getting my point?
Yes, sir.
Okay, now the problem is, when he is going to measure 140 Newton load, right? He's attaching a load, or he attached a load, and that load is how much? 140 Newton. How much that load is? 140 Newton. But he observes that the spring is not showing 140 Newton. This is the question, right? Suggest and explain why the reading is not 140 Newton. So who will explain this? Okay, let's give a chance to Mirab first. Did you get the question now, Mirab?
Yes, sir. Maybe because the limit of proportionality it's mentioned 120.
Yes, very good. Yes, Hassan, what's your idea? हाँ जी हसन, आप क्लास में ही हैं? Yeah.
Yeah, it's because of limits of proportionality.
Yes, exactly. So till limit of proportionality, the spring would be extended proportionally for the load. So as it is more than limit of proportionality, I mean 140 is greater than limit of proportionality, that is greater than limit of proportionality. Okay, then that's why the spring would have permanent deshaping. Okay, that's why the spring may have permanent deformation. Okay, permanent deformation, which makes this inaccuracy. which makes this inaccuracy. Okay, is this clear?
Yes, sir.
Okay, so this was a question from your theory. Now we will discuss another question, and then we will switch back to the worksheet from the other stream. Okay, ready? A spring S is suspended from the clamp and in the school laboratory. The student hangs various masses from the end of S, I mean spring, and determines the extension X produced by each mass. Calculate the weight of 250-gram mass. Oh, what a easy question that is. Okay, what to do then?
Sir, there is a formula for weight. I don't remember
Yes.
it, but maybe we're gonna use that.
Okay, yes, exactly. We will use that. So, Hassan, are you there? Yes, Hassan is there.
W is equal
Hassan?
to mg.
W is equals to mg. Very good. So the formula is W equals to mg. So now Yahya will tell me, do I use this mass or I have to convert this?
Um,
Yeah. What's your idea?
Count the kilograms.
Yes, it must be converted into kilogram. So your 250 grams would be equal to how many kilograms, Mirab?
Yes, sir.
250 grams will be equal to how many kilograms? This is 250 grams. Okay.
2500.
250 gram is equals to how many kilograms? 2500.
Yes.
Pakka?
2.5. 0.25.
Yes.
2.5.
0.25. Yes. देखो,
0.2.
this is in gram. आपको कोई बोलता है यार, I have given you 250 grams of sugar. तो इसका मतलब तो ये नहीं है कि उसने 2500 kg आपको प्रोवाइड किया या 250 kg प्रोवाइड किए. सो 250 grams divided by 1000 करना पड़ता है. ठीक है. So when you are going to convert it into kilograms, you have to divide it by 1000. So it would give you 0.25. Okay. So you have to convert this mass first. 0.25 into the value of G is 9.81. Right. Simply 9.8. So what will be answer? Yes. Calculator one. Should I?
सर ये 9.8 कहाँ से आया है?
Actually, this was 10 before. Before we were using this 10, but instructions are that now use 9.8. 9.8 आपकी G की वैल्यू है. ठीक है. पता
सर
ना
ये
G की
कहाँ
वैल्यू?
दी गया है?
ये कहाँ दिया हुआ है? This one. ये ग्रेविटेशनल एक्सेलरेशन है. So ग्रेविटेशनल एक्सेलरेशन की वैल्यू आपके पास कितनी होती है? On the surface of the earth, it was used 10 before. लेकिन अब उसने recently in these 2 years we are using 9.8. ठीक है.
Yeah, okay, sir.
या क्लियर है? हसन क्लियर है बच्चे?
जी 2.45.
2.45 Newton. So it is 2.45 or almost 2.5 Newton. तो हम इसको basically 2.45 लिख सकते हैं या 2.5 भी लिख सकते हैं because there is no reading at all. 250 gram, 25 gram, 250 gram है. तो it can be written as 2.5 Newton, no issue at all. Okay, but you have to write unit as well. Without unit, it will not work. You will not be able to get 2 marks. Okay, is this clear?
Yes, sir.
Yes.
Very good. Well done. Next is we are having a student plots a graph of the force F applied to the spring against the extension X. Figure 2.1 shows the student's graph. This is force again y-axis against y-axis and x against x-axis. I mean extension along x-axis. कह रहा है कि at point P on the graph the line begins to curve. State the name given to that point. So what is the name of that point where the graph starts bending?
Limit of proportionality.
Very good. Hassan agreed?
Yes, sir.
Very good. Limit of proportionality. And Yaya, are you agreed too?
Yes, sir.
Very good. Okay, the next is state the. Oh, yes, we have stated that above. Use the section of the graph where the spring S obeys Hooke's law, F is equals to Kx, to determine the spring constant F. So this is again very easy question. The formula is given to you. F is equals to Kx is there, and K is equals to F upon X is there. So what is force still limit of proportionality or till limit of
Sir,
proportionality? Yes.
sir, I don't understand this equation.
ये F is equals to Kx वाली.
जी.
ओके मैं बताता हूँ. देखो, did you ever join a gym?
No.
Did you ever stretch a spring?
Yes, maybe.
Yes, yes, surely you did. So ये spring है ना, so it is having no extension at all. ठीक है? But when you will apply some force on this spring, F, then what will happen? The spring would be stretched, but due to stretch, you will face a force on your hand. Got it? ऐसे ही होता है?
जी, sir.
Okay, so as I stretch it more and the more and more force would be applied on my hand because I am here. मैं इसको इधर खींच रहा हूँ, this way. So it would extend or it will apply the force on my hand in this direction. This is that extension in the spring. So as I increase the extension, I will get more and more force experienced by me, or it will be applied on my hand. So I can simply say that this force is directly proportional to extension in the spring. If the spring would be at its normal position, in equilibrium position, without any stretch, it will not have any force experiencing on my hand. So when we say that this force is directly proportional, then we replace this directly proportional to proportionality sign with a constant, and that constant is K. So this is that equation which tells us about F is equals to Kx. Got it?
Yes, sir.
Okay, now this K is actually F divided by X. So what does it mean? That how much force is being applied and how much extension is taking place. So let's say, yeah, for example, if I'm going to apply 100 Newton force and I'm getting 0.5 meter extension, so what will be K of that spring? 2000 Newton per meter. Sorry, 200 Newton per meter. Sorry, 200. So what does it mean? That I need 200 Newton force to extend the spring by 1 meter. But there is another spring. That spring, for that spring, I'm applying 500 Newton to produce the extension of 0.5 meter. So that spring will have the K equals to 1000. Mirab, now tell me which spring is harder to extend.
Sir, ये 500 वाला.
500 wala. Got it? So K tells us about the stiffness of the spring. If we will have greater value of K, spring will be more stiff or more hard. And if the value of K will be less, spring will be soft. Okay, is this clear now? हाँ जी, clear है?
जी
Yes,
सर.
sir.
ओके, अब आप इक्वेशन अप्लाई करिए. सो के कैलकुलेट करना है. सो या व्हाट विल बी के फॉर दिस वन, बिकॉज आई हैव टू फिगर आउट द फोर्स. Mainly this graph is important for me because I have to figure out what is force till which uh, it is linear. So I would have to draw this point over here. So it is almost 4.5, है ना? This is your 4.5 Newton load. And for this one, what is the extension in that in the spring? It is 10 centimeter. So I can simply say it is 10 centimeter. So अब आप values put करिए. Your F is 4.5 and extension is 10 centimeter. 10 centimeter equals to how much? 0.1 meter. Okay, is it clear to you?
Yes, sir.
सो के की वैल्यू क्या आ जाएगी इसमें?
45.
यस, 45 न्यूटन पर मीटर. डन. यस मीरब बेटा क्लियर है?
जी सर.
या हसन?
Yes, it's clear.
Yes, sir.
Okay, good. And then it is said that in figure 2.2 shows a mass of 0.12 kg resting on the bottom of the box. Okay, a spring that is identical to S. I mean, whatever we have calculated, this is the same spring, but for which we worked on. Connects the mass and one side of the box. Ignore the friction between mass and the box. So it is connected from one side, and from the other side it is connected with the mass, and don't consider friction between the surface. The box and the mass are at rest. State the resultant force acting on the mass. Resultant force acting on the mass. So what do you think? What was the resultant force that was applied by the spring? It is in equilibrium. You have to state. Yes. Will anyone tell me?
सर थोड़ा ऊपर क्वेश्चन दिखाएं.
हाँ ये सारा क्वेश्चन दिखाओ. ये लो, ये उस ऊपर वाले क्वेश्चन के साथ लिंक नहीं है.
नहीं सिर्फ इसी.
हाँ, अभी जब मैं मीरब से बात कर रहा था ना, सो आई टोल्ड मीरब दैट व्हेन you are not going to stretch the spring, there would be no displacement at all. So what did you learn from there? Yes, come on, any one of you.
Sir, if it is at rest, then maybe there's gonna be nothing.
Yes, it is an equilibrium. Unstretched spring है ये. Spring is not stretched. So when you are not going to stretch the spring, what do you think? Will there be any force?
No.
No.
Sir.
So this force is 0 Newton. Got it?
Yes,
This was
sir.
the trick in that question. Okay. Should I move to next?
Yes, sir.
This part of the
Yeah.
question? Okay. अब चलिए, just try this question. All of you three, please try this question. I need to calculate tension. It is 1 mark, so you are not supposed to take more than 2 minutes.
Sir, we will multiply 2 with थोड़ा ऊपर करें इसको 1 मिनट.
इधर
जी, with 1 मिनट और ऊपर करें. They've already given it.
ओके
नहीं,
ओके.
like,
अच्छा इधर नीचे
different.
करना है. नीचे.
जी, with 0.12.
0.12. Okay. 0.12. Okay, your opinion is 2 times 0.12. Okay.
Yes.
Okay, just let's lock it. मीरब ने ये बोला है. Now yeah, it's your turn. What do you think?
Resultant force
Yeah.
0. I mean, it's
No, resultant force is done. I'm at this one part. This part.
okay. The box is full. I can't.
आसान. इसके बाद आपकी बारी है बेटा.
Okay, except so then what spring constant times the length will give the force. Sorry.
Mm-hmm.
So spring constant times the extension.
Oh, Okay, well done. हसान आप जरा मुझे कंफर्म करेंगे कि इज इट करेक्ट?
Yes, sir. K into X होगा ना, the
हाँ मेरा
constant है into
यस ये
extension.
जो
जी सर।
हसान बात कर रहा है इसको आपने सुनना है। आपने एक्चुअली फाइंड करना फोर्स F टेंशन, so that is equals to K times extension. Okay, is it
जी
clear to you?
जी
So what is K? We calculated K as 45 है ना, and what was extension? Hassan, what are you using as calculation? 2 centimeter or you have to convert it?
Sir, नहीं calculation नहीं कि मैंने सिर्फ वो बताया.
Okay, okay, okay. So Mirab, let me now. Will it be converted or we will use the value as it is?
Sir, maybe using it as it is.
Okay. Yeah. What's your opinion?
Is the constant Newton per centimeter or Newton per meter?
Okay. So as the constant is in Newton meter or Newton per
Okay,
meter.
then we convert it to meters.
Yes. We have to say whether this calculation was during this calculation this constant was converted into Newton per meter or not. If this K is in Newton per meter, we have to convert it. So it is your 0.02. Now please calculate this one. 9 Newton.
9.
Sorry, 5.
9.
हाँ 9 न्यूटन. ठीक है जी, ये बात क्लियर है?
जी.
ओके, या क्लियर?
Yes.
एंड मीरब
Yes, sir.
पक्का?
जी sir.
ओके, अब कह रहे हैं calculate the acceleration of the mass produced by the tension. So this is apart from forces, so we have to calculate acceleration. So हसन कौन सा फॉर्मूला लगाना चाहिए मुझे? वैसे मैंने क्लू तो दे दिया है. Yes, force is equal to ma. Very good. So what is the value of force, Hasan? Oh, sorry, नहीं हसान नहीं. Wait. Yeah.
So force is 9. Mass is
Force is 9 Newton. And Mirav, what is mass?
0.
0.12.
Very good. 0.12, and you will get acceleration over here. Well done, all of you. So acceleration is 9 divided by 0.12. So should I
75.
expect this?
75.
Oh, 75 meter per second. Very good. Per second square. So this was a 9-mark question, as I have explained it to you. So is this clear to all of you?
Yes, sir.
Yes, sir.
Very good. Now I will switch to another other type of worksheet what I have over here. In this worksheet, let's talk about some sort of theory questions which are over here. Yes, these are some theory part questions from this one. It is said that in figure 1.1 shows a 0.4 kg mass hanging at rest from the spring. Remember this thing. This is very important information. State what is it mean by the mass of an object. ये तो आपसे नहीं
Amount of
पूछना
matter.
पड़ेगा. Amount of matter.
Matter?
या amount of matter in a substance ही कहते हैं usually. Amount of matter in a substance. Is it true? Yeah. Are you agreed?
yes.
Okay. कह रहा है कि on figure 1.1 draw the arrows to show the direction and line of action of each of two forces that act on the mass. Write the name of the force next to each arrow. So yes, which two forces are acting on this mass? Mirab, it's your turn now.
So repeat your question.
Here, this is part B. It is said that there are some forces acting on the mass. on this mass. Okay, and it is asked that draw two arrows to indicate the direction of those forces, as well as write the name of those forces.
Sir, extension.
ओके, एक्सटेंशन फोर्स तो नहीं होती, एक्सटेंशन होती है. ओके, चलो दूसरी बताओ.
I'm not sure.
Oh, when there will be a mass, will there be any force acting on a body?
Acceleration.
Okay. Okay. मैं करेक्ट करता हूँ, डोंट वरी. यस हसन.
Sir, weight.
Okay, when there will be a mass, there will be a weight, right? So one is weight. So weight की direction तो मैंने ऐसे ही बना दी, but you should know that weight is acting downward, right? It is mg. Now what will be the second force? Yeah.
Yes, sir.
What would be the second force and what will be its direction?
Second force will be upwards.
Upward, and what will be its name?
The tension or what?
Yes, tension of the spring. अच्छा, मेरा बात सुनो बेटा. Acceleration is not a force. Extension is not a force. Forces आपने बतानी है कि which forces do I have over here? One force is weight, the other force is tension. You can name forces. Can you name the forces? Do you know in your life? कोई forces बता दो मुझे जिनका आपको पता हो.
Weight.
Okay. और शाबाश. Carry on. There are so many forces in our daily life.
Sir, बस यही, मुझे और नहीं पता.
नहीं, तुम्हें पता है. फ्रिक्शन नहीं पता?
Yeah, friction.
टेंशन भी पता था ना?
जी.
यस. उसके बाद अपथ्रस्ट. इसका नहीं पता था?
Nope.
ओके, नो प्रॉब्लम. सो मेनली आपको वेट, फ्रिक्शन, टेंशन, एटलीस्ट ये तीन फोर्सेस लाजमी पता होनी चाहिए. ठीक है,
जी.
नो प्रॉब्लम. नेक्स्ट. ओके, द ग्रेविटेशनल फील्ड स्ट्रेंथ इज. ओके, यहाँ पे देखो उसने मेंशन कर दिया है. एक पुराना क्वेश्चन है, दैट्स व्हाई इट इज 10. Then calculate the size of each force acting on the mass. Wow, what a question. If gravitational field strength is 10, so you have to calculate each force. तो मैंने वैसे एक का फॉर्मूला तो लिख दिया है. I have written formula for one. So W is equal to mg. So first I have to calculate W. W is basically mg. तो आप लिखोगे the first force is, I mean downward force is m into g, where mass is, what is mass of that? 0.4 kg. So 0.4 into 10, because it has given 10 over there. But remember this thing, as I told you, that now the instructions are very clear that you are supposed to use 9.8. So it would give you 4 Newton. Now I have calculated one. Hassan will tell me, sorry Hassan, yaar, sorry I mixed the names. Hassan, आप मुझे बताइए कि what will be the value of the other force? Second force. ओके, जल्दी शाबाश, टाइम नहीं है. या आप बताओ. Yes.
Yes, sir.
Yeah, let me know what is the second force, the magnitude of second force.
Oh.
मीरब, इसके बाद आपकी बारी बेटा, इसलिए सोच लो जब तक क्या करना है. नो. ओके मीरब.
सर वो टेंशन है ना दूसरी फोर्स.
हाँ, तो ये कितनी होगी? एक्चुअली क्वेश्चन इज कैलकुलेट द साइज, तो इसका मतलब वी हैव टू टेल हाउ मच फोर्स दैट इज. तो कितनी
सर
फोर्स
इसका
होगी?
फॉर्मूला क्या है? फॉर्मूला कैसा है इसका?
इसका फार्मूला नहीं लगेगा यहाँ पे.
नहीं तो फिर
यस.
सर ग्रेविटेशनल फील्ड स्ट्रेंथ है, ये मास माइनस करेंगे.
ओ या देखो, इट्स अ डिबेट. आप लोगों को ये मतलब कोई प्रॉब्लम नहीं होना चाहिए. आई थिंक सो इट्स नॉट अ बिग इशू. ऑल ऑफ यू आर लर्नर्स.
6
हाँ
6 10 minus
Okay.
4.
Okay, 10 minus 4. So if I give you one clue, all of you, so will you
Oh,
people?
wait, it's 4 hanging at rest.
You got that clue, man. This is in equilibrium. This is at rest. Check this one out. ये बात समझ आई है? When the spring is at rest,
tension will be zero because it's
no,
at
no.
rest.
हाँ, लेकिन
Oh,
tension
then
will
it
be
can go down.
tension will not be zero because the spring is stressed na due to this weight.
Oh yeah.
ऐसे ही है ना? So if it is at rest, it is having both the forces equal in magnitude. हसन बेटा बात समझ आ गई?
जी.
Yes. Very good, all of you. आप लोगों ने सबने अच्छी एफर्ट की है. So this is 4 Newton. This is also 4 Newton because both the forces are equal and opposite. That's why spring is at rest. Got it?
Yes.
ये इस क्वेश्चन की ब्यूटी थी. अगले पे आते हैं. The mass is pulled downward. Now it is another horrible part. I mean, consider it. The mass is pulled downward. State and explain what happens to the upward force. First turn is from Hassan. Yes, Hassan.
Sir, the upward force increases.
Oh, good. Shabash. Yeah.
Yeah. Upward force, it increases.
Sorry. Upward force
Increase to
increases.
come against that pull.
Yes. So, Mira, what's your idea?
Yes sir, it will increase.
इनको सुन के नहीं बताना. ये दोनों बहुत टाइम से पढ़ रहे हैं साथ, तो ये एक दूसरे के साथ ना एडजस्टमेंट कर लेते हैं कि whenever one answer is correct, दोनों कहते हैं हाँ यही सही है. तुम अपना लॉजिक बताओ.
सर ये है कि if it's pulled downwards तो फिर ऊपर का जो फोर्स होगा वो ज्यादा हो जाएगा.
यस, बिकॉज यही चीज मैंने आपको समझाई थी, स्पेशली आपको समझाई थी अभी कि व्हेन इट इज पुल्ड डाउन एक्सटेंशन इंक्रीजेस. सो व्हेन एक्सटेंशन वुड बी इंक्रीज, upward force would be increased. Very good, yeah. Excellent, all of you. So you will say that here there are 2 marks. Remember this thing. देखो मैं why I used to discuss this worksheet with you people during my class, because I want to improve your grades as well along with the concept. यहाँ पे लिखा हुआ state and explain. So if you have just stated increases, you will score 1 mark. Okay. So when you write that y increases, then you will score the other one. So increases because extension increases, and force is directly proportional to extension. Force is directly proportional to extension. Is it clear?
Yes.
आपने extension increase किया तो your force would be increased, and so we are going to justify our logic or our actually answer जो है. अब मैं this is
Sir,
हाँ जी.
sir I have to go.
Oh, okay. Do you have any other class ahead?
बस सर आपने स्टार्ट करना है ना नेक्स्ट मंडे से.
हाँ.
जी इंशाल्लाह सर आई विल ज्वाइन.
Okay. So I
Thank
will
you, sir.
set a timetable, then inshallah we will be in contact, right?
Sure, yeah, sure.
Okay.
Okay,
Thank
Allah
you.
Hafiz.
Okay, Allah Hafiz. अच्छा, yeah. This question is specially dedicated to you, man. Okay, are you there?
Yes, I'm here.
Okay. The length of the spring is measured when various loads from 1 Newton to 6 Newton are hanging from it. Okay? Various loads are there. हसन आपने भी जाके बैठना है, मतलब डेडिकेशन मीन के आपने भी हेल्प आउट करनी है इसमें. The graph is shown. Using the graph, find the length of the spring with no load attached. How to do that? चलो आप मुझे बता दो कैसे करेंगे. Then I will let you know what is the value.
So we draw this line all until x equal to 0, and we'll find the unstretched length, the original length.
In this way? Do you mean this way?
Yes,
Wow. You spoke over there and the line was drawn. Wow, Hassan.
Hmm.
देखो ना कितनी मैजिक बात है ना. So is this the unstretched length?
Yes.
Very good. So how is that? 5, 6, 7, 8, 9, 10. Oh, no. 5, 6,
What is
7, 8, 9 and 10 है ना? So it is
Yes.
9.5.
8.5.
8.5, 6, 7, 8, 8.5. Very good. So it is 8.5 centimeter. So what will I write? It is 8.5 centimeter. Sure.
Yes.
The length of the spring with 4.5 Newton attached. Now you have to find when the length of the spring, sorry, what is the length of the spring when 4.5 Newton is attached? So क्या करेंगे हसन, अब आप बताएंगे बेटा. 4.5 find out करना है हमने. 4.5 is 1, 2, 3, 4, 5. Here is 4.5. So go straight up here. है ना? Then
Yes.
go straight left. So this is that this is that length. So 15, 19. है ना? Is it 19?
Yes.
So this is 19 centimeter. So I will write 19 centimeter. So the next step is extension of that. So yeah, how to calculate the extension? Yes.
we'll find 4.5.
Yeah, 19 minus
4.5.
8.5. 4.5 क्यों?
नहीं sir, 8.5.
Yeah. 19 minus 8.5. Yeah, agreed.
Yes,
Okay.
10.5.
8 point नहीं 8.5 तो नहीं.
10.5. 10.
10. Oh, sorry sir. तुम शादियों में चावल खा खा के ना तुम्हारा गला बैठा हुआ है. 10.5 centimeter. Okay. We all missed यार. तुम पिछला पूरा वीक नहीं आए. तो फिर तो मुझे तो कहना ही पड़ेगा ना कि शादियां खाते रहते हो तुम.
सर पिछली वीक तो क्लासेस ही नहीं थी. वीकेंड को थी सारी क्लासेस.
Okay. So is it clear? ये क्वेश्चन क्लियर था सबको? मैं कुछ और
Yes, sir.
क्वेश्चन ढूंढ रहा हूँ which would be a bit harder question. Okay. Let's check the other worksheet. Maybe we can get a harder one in that one. Yes. Oh, yes, this one. This was wonderful question. Okay, Dee, are you people ready?
Yes, sir.
Okay. Just in short time, because I have another class ahead. 4 students A, B, C and D. बल्कि आप लोग इसका एक snapshot लो ना जरा जल्दी से, because it would not be completed in 2 to 3 minutes. So I have to switch my class. 4 students A, B, C, D are having the spring. They measure the length of the spring. Then the springs are stretched by different loads. Their results are as shown in the figure. Picture ले ली snapshot.
जी.
Yes, yeah, you did as well. Yeah, can you take a screenshot, please?
yeah, I took.
Okay, then take this one. Wait. Yeah, this one. Done?
Really? Yeah.
Okay. And then this one. This is an assignment for you. Okay?
Yes.
You people will solve and send it to me at WhatsApp.
ठीक है sir.
Okay? Is it a hard task to do or not?
No,
No,
sir.
no.
Okay. Then take another picture.
Sir, it is very hard.
Okay. एक मिनट देखो जरा. Yeah, let's see फिर then ये वाला कर लेते हैं.
Sir,
Yes.
can you show the table again? The screenshot was.
Oh, sorry. This one?
Yeah. I need to take it again.
Okay, wait. I will send you this worksheet. No problem. Don't take any screenshot. Question 6, 7. Note down just question number. Okay?
Okay.
Okay?
Yes.
Yeah. Question number 6, 7, and 8. These are your home tasks. So you have to solve these 3 questions. I believe that your work and this deformation would be perfect. Okay?
Yes, sir.
Okay. See you inshallah then.
Allah Hafiz, sir.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz. Allah Hafiz.